So in this video, we are going to look back of the envelope estimation. Back of the envelope estimation. So in this, whenever we get some problem, basically this is a high level design. If we, for example, take a URL shortener, if we are getting the problem, we need to estimate the back of the envelope. For example, how many requests we are getting, how many data we are going to use, what is the DB size should be, all these things. These are all back of the envelope estimation. Actually, before doing that, we need to know some concepts. For example, these are 10 to the power 3 would be 1000 that can be represented as 1 KB. Remember KB, which KB means capital B means 8 into KB. Okay. So similarly, 1 MB, 8 into base, 1 GB equal to 8 GB, something like that. Okay. So 10 to the power 6 will be represented as million, then billion, then trillion, then quadrillion. Okay. 10 to the power 9, 10 to the power 12, 10 to the power 15. 1 MB, 1 GB, 1 TB, 1 PB. Okay. And also, when you are purchasing a server, they will mention some 99 and some uh, with the floating point they will mention this much downtime. So that means 99 percentage means they are telling approximately 3.6 days downtime per year is possible. Basically, this is downtime per year. 99.9 percentage means 8.7 hours approximately. 99.99 percentage means approximately 52 minutes. 99.999 percentage means 5 minutes. So basically we need to choose this if cost permits. If not, at least we need to choose this. Okay, if we choose this server, then we'll face a serious issue. So now we'll take example and look into that. How we are going to use this represent data and all. First, we'll take a URL shortener. Let's say in this problem, we are URL shortener. It's like a bitly. Okay. Basically, it has a long URL. We need to short that. For example, bit.ly a b c d e f some 6 or 7 digits. Okay. Basically, they will use 6 or 7 digits. Okay. So when user provide a long URL, then we will return some short URL. Okay. Uh, to access this URL, when user using this URL, then it will hit our DB, then it will retrieve the original URL. The basically it's like a concept like DNS. When you are hitting google.com, it will go to the DNS and DNS will return the IP address, something like that. Okay. If google.com is a short URL, so they can use it. If it is a long URL, then they will use this URL shortener service like Bitly, where they will use this provider where they will give a short URL, and using this URL we will retrieve the original big URL. Okay. So for each consider for each URL, one URL equal to 500 bytes. Okay. and one each URL contains 500 bytes. So we need to store it in the DB. Okay, so uh, uh, let's say we are going to handle 1 billion URLs per day. It is a maximum, but we are saying okay. Our service is a huge gig, so there is a 1 billion URLs per day, or let's say 1 million. Okay, 1 million is 10 to the power 6. Okay, so 1 million URLs per day is our request. Okay, then 1 million URL means so total URL per day is per day equal to 500 bytes single URL into 1 million 10 to the power 6 equal to 5 into 10 to the power 8. So that is 5 uh, 500 10 to the power 9 is GB. So 500 MB. Okay. Because 10 to the power 9 will be GB. So it is half of that. Okay. 10 to the power 6 would be MB. Then 10 it is 10 MB. Then 10 again 10 to the power 8 is 100 MB. 100 into 500 500 MB. Okay. Then what would be the second? How many URLs will handle per second? So for that, one day equal to 86,400 seconds. So in this, we should not take precisely 86,000. We need to make it approximately 1 lakh. Okay, because if we round off, it will be easy to estimate. Okay, so request per second would be 500 MB data per second. Or first we'll say request per second. So request per second will be 10 to the power 1 million is 10 to the power 9, right? So 1 10 to the power 6 by 50 10 to the power. So only 10 seconds per second we need to handle 10 seconds. Okay, and data per second will be just 5 KB. Basically this is write per second. Okay, this is per second. If we consider the whole year, whole month equal to, this is our day, right? Month is 500 into 30, actually it is 500 MB, 1500 10 to the power 6. So that is 10 to the power 8, 1.5 900 GB. 1.5 GB we are per month. Oh, no, it's wrong. 900 would be 3 zeros. So we missed one two zeros. 15 into 10 to the power 6. So this 15 GB per day 500 MB and per month 500 GB. Per year will be 15 into 12 GB equal to mm, 150 plus 30, 180. 180. So 180 GB per year will be used. 180 GB per year. Okay. And now in this 180 GB per year, if we store it in a single DB, it will be cause a single point of failure. So basically, in real world systems, basically they will do replication. Okay, so replication would be generally replication into three. Okay, so we will store three copies of the data. So that means into three data per year would be 180 into 3 equal to 0, 540 GB per year. Okay, and not only that, we won't store only the URL. We will store some indexes plus metadata like the timestamp and some flags and all, right? So index plus metadata. So generally the that cost 50 to 100% of the data. So that would be into two. Okay. So 540 into two. That would be 1080 GB per year or 1 TB per year approximately. And what would be the our request per second is 1 million URLs, right? And in that 10 to the power 6 request we will get. So in that per second 10 to the power, so basically reads would be 10x reads, 10x writes, correct. So what is the write? Write volume will be 10 to the power 6 and 10x reads means so 10 into 10 to the power 6. Okay, so now the request per second is 10. So the QPS would be read would be 10 requests per second. Sorry, write would be 10, 10 requests, and read would be mostly 10x read, 10x write. Okay, so 100 requests. And if we use Redis cache and all, then 95% request would be handled. So only 5 requests per second will be go to DB. And there is another thing we need to consider, that is sharding. So if we have this many request, then we can't store in a single database. We need to use sharding, right? So in that where we can use a hash-based sharding and or range-based sharding. Range-based sharding is not ideal for this scenario, so we need to use the key-based hash key-based sharding. So apart from that, we need to consider load balancer, then CDN, and load balancer detail scaling, data scaling control there, CDN content delivery network control there, And could you please second also we have covered and retention. There is a retention policy. So in this retention policy, uh, there can be free user and premium user. So free user, the data will be stored for 1 month. Paid user, data can be stored permanently to avoid usage. And we have a bandwidth incoming and outgoing. Result with 10 request incoming and 100 request outgoing. There is no much difference. So this is very less. If we, in case if we handled handling 1 billion requests per day, so in that case it would be huge. It would be 10 to the power 4. This would be 10 to the power 6. So that time it would be the bandwidth would be huge. And that's it. We have covered everything. Thanks.